also feel the need for technical intervention. Some new technology needs to come. In these regions, you rarely have alternate access. So if you have 3 landslides, you go on clearing one by one and only then you reach to the other end. Unless, of course, when our friends from the Air Force help us, we can reach to the last point, but that is a very costly and rarely used alternative. Most of the roads remain closed during monsoon season due to slides and falls, and it hampers economic activities and development of these areas. Next, please. Next. We will be looking at 3 technologies. One is the application of GIS in alignment planning. When we are constructing a new road, we need to plan the alignment in a manner that it avoids landslides and rockfall areas to the extent possible. Next. This is what is called soil nailing. Next. This is deep anchoring. Next. This is what is trimming and benching. Again, it is not popular because a lot of cutting is involved in a very ecologically sensitive area. Next. Next. This is what you call a rock catcher. First one. The second one. The second one is the debris flow barrier, and the final one is shotcreting. The first 2 are case studies from India only. The last one is not Indian. Next. Next. This is where we put a net onto the sides to prevent the rocks from falling onto the road. So this is again a place near Nashik where we have used this type of thing. Next. This is a rock shed where the land is such that there is no way you can avoid landslides. Obviously, it's a very costly proposition where you make a concrete shed over the road itself. Next. Then we come to the drainage part. I will take another 2 minutes. We come to the drainage part. We all know that drainage behind walls and retaining structures is one of the major problems, and the type of traditional drainage that we provide have not been working. This is a new technology where geotextiles and geocomposites are used behind retaining walls and even underneath the pavements. Next. This is where you provide a textile below the pavement, and it allows the water to pass through below the pavement. Next. Next. This is how you install it. This is a schematic diagram of how it looks after it is done. Next. These systems are much better. If you see the photograph, there is a pipe coming out, then there is some composite just behind the retaining wall. These type of systems are much better because they do not get clogged by fine soil particles. And it has a much larger drainage capacity and it requires no maintenance. Next. I hope I have been able to convey the things that we wanted to do. As a last thing, I would like to add that these are the technologies that we are looking at for the future roads. So normally you have case studies, and in this case we will be having the study first and the case later. Thank you.
Informative and well-engineered presentations for non-engineering persons like us. Now my question to Dr. Soni is, what you have rightly said is earthquake doesn't kill, but the collapse of the building does. Now we are all aware, we have seen so many heritage buildings going across so many earthquakes, but standing still for last 100, 200 years. Now the question is, do you still believe that the earlier design, engineering and the architecture was much advanced than the present one? And the second question to Mr. Shailendra Sharma is, as he has given the example of the Japan is to be inside the building, and second is he has spoken about the low collapse design. My question is, now we go to all the builders, they speak about the ash bricks they use in the high-rise building. Are they safe as a earthquake resistant buildings?
Let me tell you one thing, that old structures, whatever you call it, that heritage structures, Not necessarily that they are all safe, but most of them, yes. See, if the structure is behaving in a monolithic way, wherever it will go, whole structure will go, it will not fail. You understand? If I am here, my body is here. If I am, suppose this hand is broken from here, it will not stand pressure if something is pushing me. If I am okay, if this suit is okay, I have tied it, then any lateral force will not affect me. Basically in earthquake, if the structure is acting in one way, one monolithic way, it will not fail. All the old structures which you are talking, their mortars, their workmanship, their material that is acting in one way, in monolithic way, in a single manner, it will not fail. There are few structures which are heritage structures. They are not all structures. See, from the centuries, all brick structures, stone structures, they are not still there. They have fallen or they have outlived their life. There are only few structures which are safe, even today. See, if the engineered structures are there, they are not failing. Mind it. If you are designing your structure for lateral loads, after what is in earthquake, somebody is, say, shaking you. It is like this. Somebody is shaking. So, some forces are shaking the structure. So, if suppose structure is going this way, this way, this way, or this way, or upper way, or lower way, it will not fail. So, if structure has been designed as per them, there is no problem. Now, what I am saying is that most of the structures, even in small villages, rural areas, small towns, even in Delhi or say Visakhapatnam, those structures are not designed by the engineers. So what will happen? Somebody will come and will say, I'll construct you for this type, this type. You provide it. What you can do it? You can make it safe by seismic retrofitting. And that cost, initially if you have done, then that is something 5% or 2%. See, if you initially do during the construction, cost is only 2%, at the most 5%, that's all. What you have to do is to put some band, something in this way that whole structure will act in single way. So there is no problem. Now, if you do afterwards, then there is some, you have to see some bands will come, something will come, but the cost will go up. Cost may go up by say 6% to 15% or 20% at the material, whatever you use it. So even it is better. If the structure has fallen during the earthquake, then it is fallen. It will say you have to go for a new structure, or maybe 50% cost, 70% cost, 30% cost. What I am saying that let us start awareness, let us do the awareness so that seismic retrofitting of the building is done even before failing, so that it costs only 10%. That's all. Or 5 to 10%. That is one part. Second, you talked about from Mr. Sellen, the fly ash bricks. You see, fly ash bricks, if they are as per the standard, they are as good as your brickwork, as clay bricks. There is no problem. Normally, bricks in RCC construction, they are not the load bearing. For RCC frame is the taking all the loads. They are infill walls. If infill walls are there, we designed even if failed doesn't matter. But fly ash bricks, what you are saying S, whether they are safe if they are constructed, they are as per IS codes. There is this Indian standard codes where the fly ash quality of fly ash is prescribed, compressive strength of the fly ash bricks is prescribed, water absorption is prescribed. So if it is as per those, there is nothing wrong in fly ash bricks because they are considered environment friendly bricks. I think you are satisfied with my answers. If not, yes, please. Okay, thank you.
Roofing material, which is called profiles. And what's happening is, the stresses are there. The stresses are there, and on that there is a hollow pipe. And screws from the top are being put into this hollow pipe, square pipe. Now, usually when the Hudhud type cyclones come, the sheet is pulled out. Will there be a better option like putting all along the perimeter on the outside or inside and no, so, okay, on the outside, and putting the screws from the inside all along the perimeter so that the edges are not blown off. I mean, is it a new novel technology?
No, actually, what you are talking about is self-tapping screws, probably
Yes.
fitted from top.
It has a small washer.
Yeah. I think in cyclone areas, as I mentioned in one of my slides, it is definitely good practice to provide, not only good practice, it should be provided. We should provide steel straps along the edges where maximum pressure take place. That is along the edges, along the ridges, and there can be cross bracings also top and interconnected at crossover points. They are recommended for cyclone areas. Definitely that will ensure that this kind of, a large scale failure which has taken place in our airport, that would not have occurred if that kind of additional protection is provided. Definitely, yes.
One more small question, sir. These fly ash bricks, they have contained lot of radioactive material, and that's what people say. It's controversial. So they say there is possibility for radioactive pollution. What is your opinion?
As a civil engineer, I am really not aware of the radioactive potential of fly ash and fly ash bricks. It may be true for some particular brick. I do not know. We have not really tested them for that. But as far as we know, there is no such problem. We are concerned with the structural properties, as he mentioned, and the kind of fly ash bricks we are getting in Andhra Pradesh and Telangana, they are very good capacity. Normally we need 75 kilogram per square centimeter. We are getting of the order of 100 and more in most cases. Water absorption is also not much. So truly speaking, I am not the right person to comment on this. We are not aware of any health hazards as far as fly ash bricks are concerned. Maybe some other agency who has done more on this can be able to tell you. Thank you.
Again, first question, as he told that you have J hook in place of J hook, you should have U, so that it is that. Second, fly ash, I don't think it has UV, any radioactive material. See, basically it doesn't have. You see, basically this materials comes from, thermal power plants. And it is used in many applications. It's not only in bricks. It is used in concrete. It is used even for the agriculture purpose also. And I don't think there's any radioactivity really in the fly ash bricks. It is all over the world. Fly ash is now being used as a resource material rather than now as a waste material. It can be used in cement, whatever you get from the market, Portland Pozzolana cement, that contains about 20 to 30% of fly ash. So all the cement which you are getting market, that has the fly ash up to the extent of 30%. And also you can use in ordinary Portland cement about same quantity of fly ash. So it's not only in bricks, it is used in number of applications. So I don't, you please, you should not worry for the radioactivity on that one.
Just a comment, especially after Uttarakhand disaster, we gave our input that while constructing a road in the hilly terrain, after every 15 to 20 kilometer, you have to identify an area which can be, in a broader size, which can be used as a helipad in case of a disaster. And after every 80 to 100 kilometer, a much broader space, where the storage for the fuel is also there. Of course, in this BRO will be there, CPWD is there. More importantly, actually the state government will be involved. So the representatives from state governments, they need to think, especially the hilly region people, that this is also one of the suggestions post Uttarakhand disaster, that we need to construct such kind of a designs over there. Thank you.
And my question is directed to Mr. Shailendra Sharma. Sir, during your presentation, you have told that particularly during the earthquakes, majority of the buildings that get damaged are which are made of brick and mortar. And then you are also talking about certain new buildings where if they are not properly designed, like lot of glass, it is made of lot of glass structure, they also get damaged. Now my question is, certainly those new buildings which have been constructed, have been done under the supervision or constructed by engineers and architects, highly qualified people. If that is the case, why such things are happening? Is it because the management is not allowing the engineers to do their job, or they are not able to strike a balance between the aesthetics and the engineering codes into consideration? Thank you.
If you remember, right in the beginning of the session, our special DG mentioned a few things, and maybe some of you must have smiled and smirked at what he was saying. But there are few issues of, so to say, management of technology in our country, building technology. This sector is still quite unregulated, and there is no system of exams which designers and engineers have to pass. Once having studied their engineering, they are qualified to do the structural design all through their life. They may be outdated, they may be doing wrong things. No, there is nothing to punish them. If you, compare this with the kind of licensing which goes in case of doctors, their license can be withdrawn. In US, every few years, a person has to appear for exams to qualify for this kind of work. That kind of thing is not there in our country. What to say of that? Even our municipal administrations every year are not insisting on strict implementation of earthquake codes. And this is one of the reasons why failures have taken place. I'll tell you, there is a clear difference. There's nothing like a real life experiment. In Bhuj earthquake in Gujarat, so many structures have damaged. I would have liked to show you some photographs. Because of paucity of time, I cut short my presentation. None of the CPWD buildings has been damaged. Why? Is it surprising? So many buildings we have constructed in Gujarat, and we have been using these very codes for the last 30 years. As a result, not a single CPWD building suffered damage. In this huge earthquake of Gujarat, where thousands of buildings have been damaged, so many people have been rendered homeless, and millions have been, in terms of property, have been lost. So there is a problem. The fact is that we need better regulation. We need better certification in terms of engineers. There has to be liability of the engineer if he does a wrong design. There has to be liability of the builder if he fools by saying that I have done this, made this building using earthquake resistant design, and it is not. Those kind of things are not there at all, because all these things have been discussed. We have been party to those committees. Ultimately, it comes down to implementation at the municipal level. And I think as a result of our discussions like this, the awareness is growing, and slowly we are moving in that direction, but we are not yet there. So that's all I can say at this stage. We are moving in that direction, not yet there. And we hope by talking all these things, I know fully well that I cannot teach you entire civil engineering and earthquake engineering or wind engineering in just 20 minutes. But you are asking this question, this itself is good enough. This is success enough. You are now aware, and as citizens of this country, as we become more aware, as more and more people ask these questions, ultimately these things will be implemented better. Thank you.
Your question, I think, was on glass, isn't it? See, glass is fascinated material for the architects, with due regard to all architects and also to individuals. Glass is considered a fascinated material for the architects and some of the individuals. They want glass, glass, and glass. Now glass has come. Glass is a good material, and glass is a very bad material. Glass, basically, some people like because it is very, smooth and all that, and transparent. But see, the designing part of the glass, particularly the facade, this facade designing has still not come to India in all the spheres. People come, they fix up the framework, they fit the glass, that is all. So that facade work is not designed. When it is not designed for the loads, it fails. Simple. Because as we are talking about the designing of the buildings, other walls or slab or beam, similarly, until and unless glass facade is designed for the loads, it will fail. So that 90% cases in India, that is still not designed, that is provided just for the purpose, aesthetic purpose, and also for gravity loading. That's all.
As from technical side, I have shifted to administrative ones. There is a word techno-legal regime. Simple thing is National Building Code has to be fully not only incorporated or to give the reference, it has to be executed with authority of law. That is in the state government's hand. We are finalizing NBC 20515 also. And the bylaws, there are the references, but we don't have the check. For example, on 18th, when I reached here in the evening with one of my friend and my wife, I traveled on the beach. It is something like Marine Drive of Bombay. I found so many buildings coming up. The minimum mix for Vizag should be M35 because of the sea. And from the look, I can say that so many multi-story coming up are not more than M20. Now here, our, I think Chandrababu Naidu is the best chief minister India has ever had. And under his, guidance or whatever say control also, this should not take place. There should be a check. Either the builders should be educated or the structural engineers should be given a free hand as well. What happens in building? The builder will say, you have to put this much amount of the steel. Now it is up to you where you have to put it. Now that is the problem. Safe design means, ductile design means, we have to have good concrete and certain amount of steel placed at certain places. For example, for earthquake consideration, this place will be very low, cyclone high. Now, if somebody says me that no, in a building design in Chennai, the steel was only this much, and in Leh, why are you using this much? The structural engineers are facing that. And still in the private field, our architect friends are having upper hand. So while, busting the structure, we are forced to keep the expenses on steel at the least. Otherwise, if you calculate the total cost of the structure, all furnishing, everything, then it is hardly any fraction. So my appeal is, for your own safety, please allow the structural engineer the free hand. He should not be forced to reduce the steel. Everybody can say National Building Code for your area, what is the mix required, your sizes. Everywhere they can see. Then I think even so many legislations will not be required. My chairman will be summarizing, but my final call, do not, invite the disasters by making weak structures. Thank you.
Thanks to all the panelists in the session, those who have deliberated on the subject related to the disaster management in the pre-disaster and post-disaster. Pre-disaster management is much more important, and everybody except Mr. Jha, who has spoken about the post-disaster needs and post-disaster management, or Dr. Soni has spoken about the buildings. It is the buildings which make the people killed. It is not the natural hazards. There is a need to strengthen the existing buildings, and there is a need to ensure that the new buildings, which whatsoever they are constructed, they are made disaster resistant. Similarly, Shalini Sharma has also emphasized the similar point. Whatever natural disasters are there, like wind and cyclone or seismic, those appropriate precautions have to be taken care of at the incipient stage, at the initial stages of the construction. If all these things are taken care of, including the road, Mr. Roy Chaudhary has said that I think there will be highly reduced post-disaster management requirements. So under the circumstances, techno-legal regime, which had been a very, very important component while the NDMA was enacted, before the NDMA was enacted, but unfortunately, in our disaster management system, Disaster Management Act, techno-legal regime has not been given any weightage. My submission to the organizers of this Second World Congress is that techno-legal regime has to be an important component, and in the board of the directors or whatsoever it is the NDMA, those people are there, they are all bureaucrats. There is not a single technocrat there, and as a result, they do not understand the necessity of the techno-legal regime. I am of the firm opinion, even at that time I had given in writing to the Ministry of Urban Development that techno-legal regime is not there in the draft act. Even despite my writing it, it has been totally ignored by the bureaucrats comprised of the IAS officers, not technocrats, and as a result, this is what we are seeing even now. After almost 10 years of the enactment, 12 years of the enactment, even now there is no talk of techno-legal regime. Rather, engineers bill, which had been deliberated by the Parliament Special Committee, that engineers bill has been set aside. Our bureaucrats have recommended no necessity of the engineers bill. We do not want any medical council like of type of thing for regulating the engineers, and hence engineers bill is not needed. So my recommendation is there has to be a regulation of the engineering profession so that unsafe buildings are not constructed right in the beginning. Thank you. With these words, thank you.
Thank you very much. To give a token of appreciation on behalf of the government of Andhra Pradesh and DMICS to the eminent speakers, I'd like to call on stage Shri Anil K. Sinha, IAS retired, Honorable Vice Chairman of the SDMA and Minister of Cabinet in the Bihar government. Sir, could you please come on stage to give away the mementos to the guests? Ladies and gentlemen, with this, we come to the close of today's conference.